your memories of math class plagued by dull rote memorization exercises? Maybe you were forced to memorize dozens of formulae. But how much of that did you really understand? Math should not be like that. Math is beautiful. Math is about understanding. One notable formula is the quadratic formula. Let's break it down. So this formula is used to solve quadratic equations, equations of the second order, or those in the formats ax squared plus bx plus c equals 0, where a, b, and c are given variables and x's are unknown, or what we want to find. An example would be x squared minus 4x plus 4 equals 0. These equations can have 0, 1, or 2 real solutions, or solutions that exist on the number line. We can show this by drawing a graph of y equals ax squared plus bx plus c. Points where the line crosses the x-axis are solutions, as when the point is on the x-axis, y equals 0, and the equation is hence true. Since the graph has this elliptical shape, it could cross the x-axis once, twice, or not at all. If the line crosses the x-axis once, the two solutions are the same. If the line does not cross the x-axis at all, the solutions will be complex, which means that they contain the square root of -1, the value of which is undefined. Now, the solution I am about to share with you was developed by Po-Shen Loh, a professor at Carnegie Mellon University. I believe it is simple, intuitive, and teaches understanding rather than rote memorization. Here goes. So to make this simpler, I will represent our quadratic equation in the form x squared plus capital Bx plus capital C equals 0 by dividing the entire equation by a. Let capital B be b over a and capital C be c over a. Note that for the rest of this video, when I say B, I mean capital B, and when I say C, I mean capital C. The first thing I want to explain is that every quadratic equation can be represented in the form x minus r times x minus s equals 0, where r and s are actually the solutions, and you can tell this because, well, if x equals r, then x minus r equals 0, and anything times 0 equals 0. You can use the same logic for x equals s, hence r and s are our solutions. Now you can show that any quadratic equation can be represented in this form by merely cross-multiplying it out. So you get x squared minus xs minus xr plus rs equals 0. Factorize that a bit and you get x squared minus r plus s times x plus rs equals 0. And we've basically come full circle to our original equation, because if you compare the two equations, well, you can directly see that negative r plus s equals b and r times s equals c. So rewrite the equations a little and you end up with this. Now, look at equation 1. If you drew this out on a number line, since r plus s must add up to negative b, r and s must be equidistant from half that value, or negative b over 2. Let's call this distance u. Then you could represent r and s as negative b over 2 plus u and negative b over 2 minus u. Note that it does not matter whether r or s is greater, as they are interchangeable. Now we have values for r and s, and we can substitute them into our second equation. So c equals negative b over 2 plus u times negative b over 2 minus u. This is a difference of squares, and if you multiply it out, you'll get c equals b squared over 4 minus u squared. Write the equation in terms of b and c to get u squared equals b squared over 4 minus c and u equals square root b squared over 4 minus c. Wait, but remember, we know b and c, they're variables. Substitute in our values of b and c, and now you can solve for u. Again, now we know the value of u. We can substitute that into our equations for r and s in terms of u. So r and s equals b plus minus square root b squared over 4 minus c, and you've solved your quadratic equation. Now let's try an example. Solve the quadratic equation x squared minus x minus 20 equals 0. Pause the video here to try it out for yourself. So if you recall, r and s are our two solutions, and r plus s equals negative b, which in this case is negative 1. Earlier we concluded that r and s are an equal distance, u, away from negative b over 2, so that means r and s would each be negative 1/2 plus or minus a certain u. If you'll also recall, r times s equals c, or negative 20, but we can substitute our values from the previous equation into here, hence that would be negative 1/2 plus u times negative 1/2 minus u. Hence 1/4 minus u squared equals negative 20, u squared equals 1/4 plus 20, and u is the square root of 1/4 plus 20, that is the square root of 20.25, which happens to be 4.5. Hence the values for r and s are 4.5 plus 1/2 and negative 4.5 plus 1/2. that would give us 5 and negative 4. Hence x equals 5 or x equals negative 4, and our two solutions are negative 4 and 5. If you plug these two solutions back into the original equation, you'll find that both of them hold true. So congratulations, you've solved the quadratic equation! Now, there's still no point memorizing this end formula because that's no better than memorizing the quadratic formula. But now that you know the steps to solve it, you understand how it works and you'll never risk remembering the formula wrong again, as you'll just be able to rederive your solution. In fact, you may have noticed that the final equation that we got was quite familiar. You can actually use this method to rederive the quadratic formula if you don't substitute in your values for b and c. I'll leave that as an exercise for you. And with that, we have come to the end of this video. Stay curious, and I'll see you in the next one.